For centuries, sailors came home with stories about sea monsters big enough to drag a ship straight down. Today we just call it Abyssal Gigantism. Duller name, weirder truth. Because what's actually happening down there is stranger than anything the old stories invented. Let's talk about how little we've actually seen. A May 2025 study in Science Advances put a number on it. Humans have laid eyes on less than 0.001% of the deep sea floor. Add it all up and you get an area roughly the size of Rhode Island. That's the entire tally against a zone that covers 2/3 of the planet. And it's not cheap to look. Exploring less than half a square mile down there can run $2 to $20 million. So keep that in mind. Everything we're about to talk about comes from a world we've barely poked our heads into. Now, the gigantism itself. Deep sea animals tend to grow way bigger than their shallow water relatives. Not slightly bigger, sometimes 10 times bigger. Giant isopods hit 30 inches while their coastal cousins stay a few centimeters long. Sea spiders spread out to 75 centimeters across. Oarfish stretch past 50 feet, making them the longest bony fish alive. Nobody's fully settled on why, but 3 biological rules seem to be doing most of the work. There's Kleiber's rule. Bigger bodies burn less energy per pound. Down where food shows up as an occasional dusting of organic debris, marine snow, that efficiency isn't optional. It's the difference between starving and not. A big animal can gorge when food finally drifts by, then coast through months of nothing on stored fat. Smaller animals don't have that luxury. There's Bergman's rule. Cold water animals grow bigger because cold makes bigger cells, and bigger cells make bigger bodies. The deep sea sits at a steady 2 to 4 degrees Celsius, cold enough to slow everything down, metabolism included, so these animals grow slowly but live a very long time. The Greenland shark is the poster child here, 24 feet, 1.5 tons, and a lifespan measured in centuries. And there's the island rule. The deep ocean is basically its own isolated island, cut off by pressure, darkness, and distance instead of water. Cut off from the pressures that shape life near the surface. Animals down there drift toward extreme sizes the same way island species do. Throw in more dissolved oxygen at depth and fewer predators, and you've got a genuine giant making machine. Here's the part I find most interesting though, where the old legends and the real biology actually line up. Take the Kraken. Scandinavian sailors spent hundreds of years describing a sea monster so massive it could pull a ship under. A bishop wrote in 1752 that its body stretched 2.5 kilometers around. Even Linnaeus, the guy who invented the whole system we use to classify living things, put the Kraken in his first edition of Systema Naturae in 1735. He walked it back later, but still, the most rigorous taxonomist of his era once thought it deserved a real scientific name, and honestly, he was not crazy to wonder. Giant squid are real. Architeuthis dux gets to 43 feet and 600 pounds. The colossal squid is bigger still, the heaviest invertebrate on Earth, likely over 500 kilograms, with eyes the size of dinner plates. Those eyes exist for one job: spotting the glow of a hunting sperm whale in total darkness. The fight between the two happens constantly, we just never see it. Only the sucker scars on whale skin and the squid beaks left in whale stomachs afterward. No squid has ever taken down a ship. But here's the thing about the Old Norse stories. Fishermen used to say their catches got better near where the Kraken supposedly lived. Turns out that is exactly what modern biologists see around giant squid feeding grounds. People had been encoding real ecology into folklore for 7 centuries before anyone had a name for it. Then there's the sea serpent, probably just an oarfish. Long, ribbon thin, swims upright with this crown-like fin above the waterline. In Japan, they're called messengers from the sea dragon's palace, and people believed seeing one meant an earthquake was coming. A NOAA researcher summed it up better than I could. It has every quality you'd want in a sea serpent. It's also completely harmless. Some creatures don't need any myth-making at all. The big fin squid, with arms bent at strange right angles, looks unsettling on its own merits. Footage of one drifting through the dark is some of the creepiest deep-sea video that exists, no embellishment needed. And when Jacques Piccard and Don Walsh dropped to 10,911 meters in 1960, they found life surviving at pressure that would crush a steel hull. What gets me is how much is still turning up right now. In March 2025, the Schmidt Ocean Institute filmed a live colossal squid in the wild for the first time, a century after we first identified the species, juvenile, 600 meters down near the South Sandwich Islands. The researcher who confirmed it said something that stuck with me since. It's humbling that these animals have no idea we exist. In January 2025, scientists named a new supergiant isopod after Darth Vader because its head shape echoes his helmet. 13 inches over 2 pounds. It wasn't found on some expedition. It turned up in seafood markets in a Vietnamese coastal city, sold as a delicacy since 2017 before anyone realized it was a species science had never seen. And across 2025 into 2026, the Ocean Census Project found over 1,100 new marine species across 13 expeditions. Added up across the year, and marine scientists logged more than 2,500 new species in 2025, outside on 5 alone. None of this is just trivia. One researcher put it bluntly, as the deep ocean faces mounting threats, climate change, mining, resource extraction, barely having explored it becomes a real problem, not just for science, but for policy. We're on the edge of mining the seafloor for minerals in places we haven't mapped, threatening species we haven't even named yet. So where does that leave us? Abyssal Gigantism was never really about monsters. It's what happens when you combine brutal cold, scarce food, total isolation, and enough time for evolution to work slowly and patiently. The old sea monsters weren't lies. They were real biology, warped by fear and distance and a few too many nights at sea. The kraken was a squid, the serpent was a fish, and the 99.99% of the ocean floor we still haven't looked at almost certainly holds something that would make every old legend look small. We've mapped more of the moon than we have our own ocean floor. Whatever's actually down there, we've barely started looking.